Adding and subtracting fractions often represents the most challenging work that students will do with fractions. So let's just go through the process for doing that, and let's start simple. And I'll tell you what I mean by simple. Let's start with a couple fractions that already have common denominators. Right? The denominator part of the fraction is the same. If you've already got common denominators, then you simply you know two things. Number one, your answer is going to have the same denominator. So your answer will be over 11. Notice it's not 22. I didn't add the 11 and the 11 to get 22. The answer is going to be over 11. And then finally, what's going to be on top? Well, you just add. You just look at the top. You do top plus top. And so 2 plus 5 is 7. And so the answer is 7/11ths, and we quickly look at that and see if it can be reduced. It cannot, because 7 and 11 don't share common factors. But to add fractions or subtract them, this would be the exact same thing you would do if it was subtraction, except you would subtract. You must have common denominators, and if you do, then it's a fairly simple process. You just add or subtract across the top or across the bottom. Now in another video I'll describe why this is the case. This video is more about just working through and practicing the procedure. So we can do another one. We can subtract two fractions with common denominators, say 7/6 and 2/6, and we know the answer is going to be over 6, and we're going to get 7 minus 2, or 5, on top, and that is a fraction that cannot be reduced. So what happens when you need to add something add two fractions or three fractions that do not have common denominators? So 3/8 plus 1/20. Well, the first thing you have to do, and we'll put that back up here, the big rule for addition and subtraction is, in order for us to do the addition or subtraction, the fractions must have the same or common denominators. Okay. And so we need to change our fractions. And remember, let's just talk about 3/8 for a second. 3/8, there are lots of versions of 3/8 that are the same number but just look different. 3/8, 6/16, 9/24, 12/32, right? And the list goes on. So what I want to do, and I have that same kind of thing for 1/20, 2/40, 3/60, and so on. What I want to do is I want to use one of the versions from this list and a version from this list that has the same denominator, and I can add those two things. So I need to find a different version of 3/8 and a different version of 1/20 so that they have the common denominator. Alright, so the procedure for doing this is we want to find, you'll remember this, you first must find the least common denominator. Actually, we can do this with any common denominator, but if we do it with the least common denominator, which is going to be the smallest of the common denominators, then that makes our reduces the amount of simplification we have to do. So how do you find the least common denominator? Well, what are the denominators that we have? We have an 8 and we have a 20th, right? If I want to find the least common denominator of 8 and 20, I actually just need to find the LCM. And we've talked about finding the LCM of two numbers. You might want to go back and watch that video if you don't remember. So find the LCM of 8 and 20, and that will be the common denominator. So remember how we find the LCM of two numbers. You first find the prime factorization of each number. 8 is 2 times 2 times 2. 20 is a 2 times 2, that's 4, times 5. Okay, So our LCD is going to have some 2's and some 5's in it. Well, how many does it have? Well, look at the 2's and take the largest group. Well, there's 3 of them, there's 2 of them. So we're going to take the largest group, which is the group of 3. Okay. How about 5's? Take the largest group of 5's. Well, there's only one group and it has a single 5 in it. So we're going to take that. If I multiply those together, that gives me the LCM or the LCD. Let's put that in there. Multiply those together, 2 times 2 times 2 times 5. Looks to me like this is an 80. Or I'm sorry, a 40. Okay. So I want to find versions of 3/8 and 1/20 that have 40 in the denominator. That's my task. I know what the least common denominator is going to be. It's going to be 40. So now I need to change my two fractions so they have that denominator. So let's see, we're going to work right here. So we've got 3/8 and 1/20, and I want to change them to something over 40. That'll be the 3/8. All right, plus, right, it's still going to be addition, something over 40, and this second fraction will be the 40 version of 1/20. Okay, so it's going to be 40 and 40. And so now I just do this process. I say, okay, what times, looking at the 3/8 and trying to figure out what goes on the top there, what I do is I say, what times 8 gives me 40? And the answer is 5. So I have to multiply the bottom by 5 and the top by 5. And so what I'm getting is like the fifth version, the fifth number in our list of equivalent fractions of 3/8. So 3 times 5 is 15, and so that's going to go right there. And 8 times 5 is 40, and there's our 40. So just notice, make sure you understand that 3/8 is the same as 15/40. I'm kind of unsimplifying. I'm using a more complicated version of 3/8 in order to have the common denominators that I need. Well, then I do the same thing with 1/20. I want to change 1/20 to something over 40. And I do that by saying, what do I need to multiply 20 by to get 40? And the answer is, of course, 2. And so you have to multiply the top and the bottom. And so 1 times 2 is 2, and 20 times 2 is 40. And so look what I've got. I now have 3/8 and 1/20 written as 15/40 and 2/40. They're the same fractions, but now they have common denominators. And so I can say, hey, the answer is going to be over 40. And the top is just going to be 15 plus 2 is 17. And that is my final answer. It can't be reduced. Okay, so that was kind of a long process. I mean, all my talking made it longer. But you find out what the common denominator is going to be, change your fractions so they have that common denominator, and then add or subtract as the case may be. Okay, let's try another one here. Let's do a subtraction problem and see how that goes. So we would like to subtract two fractions that start off not having common denominators, and we'll then work till we get common denominators. So let's go 3/8, not 3/8, 3/7, take away 4/11. Alright, so I look and I say, hey, look, the 7 and the 11 are obviously not the same. So what's the LCM? Which is the LCD. Find the LCD, which is the LCM, right? So you factor 7. 7 is just 1 times 7. 11 is just 1 times 11. And so our LCD is going to have 7s and 11s in it. We don't worry about the 1s. Our LCM is going to take the largest group of 7s, which is a single 7, largest group of 11s, which is a single 11, and that makes 77. So I am going to change my fractions so that they are both over 77. So how do I do that? Well, I'm going to need to multiply the first one by 11 and 11. That gives me 33 over 77. And then I'm going to need to multiply the second one also by 7 and 7. And that gives me 28 over 77. And those are the same fractions. 28 over 77 is the same as 4 11ths. 33 over 77 is the same as 3 7ths. But now my answer is going to be also over 77, and I just do 33 minus 28, and that's 5. And there's my answer. It can't be reduced. Occasionally, you'll see problems like this. Add 7 3/8 and 4 3/4. So those fractions are or those numbers are mixed numbers, and there are several ways you can work with mixed numbers. Some people say just keep them mixed and kind of work within that framework, and that there's some advantage to that. But if I'm working with these, generally my approach is to change mixed numbers, to convert them to improper fractions, and then work with them as improper fractions. I found that to be easier. So how do I convert a mixed number to an improper fraction? Let's start with the 7 3/8. And the procedure is this. 8, I take the denominator times 7. So 8 times 7 is 56, and then I add the numerator. So that's 59. 8 times 7 is 56 plus the numerator, and that's going to give me 56 plus 3 is 59 eighths. These two numbers are the same. The second one is just the improper version. Okay, let's convert the second mixed number to an improper fraction. 4 times 4 is 16. 16 plus 3 is 19 fourths. And there we go. I've converted my two fractions to improper fractions, and now I can do the arithmetic. I can do the addition. So I remember, to add these, they've got to have common denominators. Now, here we see that the common denominator is actually going to be 8, because the least common multiple of 8 and 4 is 8. Oops. Let's try that again. Is going to be 8. So I'm going to need both of these fractions to be something over 8. Well, the first one is already good. 59 over 8 stays 59 over 8. I don't need to change it. But the second fraction, I'm going to multiply by 2 in order to get the 8 in the denominator. So 2 times 19 is 38, and 2 times 4 is 8. Now that I have common denominators, I see that my answer is going to be over 8. And I can add the tops, so that's going to give me 59 plus 38 is 97. And there's our answer. It's not reducible because 97 and 8 don't share any common factors, so we can't reduce it. But the question we have now is, do we leave the answer in improper form like it is here, or convert it to mixed numbers? And there is no always answer to that. So sometimes you'll leave it just like this, 97 eighths, but there will be times when you want to convert it to an improper or to a mixed number. So let's remind ourselves how to do that. If I want to convert to a mixed number, what I do is I actually do some division, right? I say, okay, let's do 97 divided by 8. So we'll do that over here. 97 divided by 8. Well, it's going to go into 9 one time. 9 minus 8 is 1. Bring down the 7. 8 goes into 17 once. Times is 8. Subtract is let's back up. Sorry about that. 1. 8 goes into 17 twice. 2 times 8 is 16. Subtract, and our remainder is 1. So all the information we need about converting to a mixed number is found in that division problem. We need the 12. So 8 goes into 97 12 times with a remainder of 1, and so we put 1 over 8 there. And so that is our final answer as a mixed number. So it's easier to work with, to change mixed numbers to improper fractions and then work with them. And then you can decide how you want to express your answer. You always want it in simplified form though, and so make sure you always reduce it.